Okay, it looks like we're going live. It says we're live, and I'm going to check to make sure we don't have an echo. Hopefully you guys can see me and you can hear me, and we don't have an echo. Everybody let me know we don't have an echo. I'm trying to make sure that all is good. You guys see 5 by 5, hopefully? Yes, yes, no echo? Still no echo? All good. Excellent. All right, so you guys can see yourself here. We are we are in yet another crazy time. The sun's crazy antics, right? We are in the middle of it, and I've put the charts together as quickly as possible without being able to go over them, you know, as kind of like a prequel here. So I will be going through the charts, essentially briefing them to you essentially the same time that I've gone through them for the first time after putting them all together. So if I miss something, you know, forgive me. But yes, the sun has been absolutely crazy busy. I am counting 1, 2, 3, 4. We have had 4 X-class flares, and I can't even tell you how many M-class flares. We had even almost another X-class. It was like an M87 or something. And this is all within the last 24, or excuse me, maybe 36, 48 hours at most. That's where the first X-class flare kicked off. So if you guys can all see me and hear me, thank you so much for being on. And for those who look for me to wear a red shirt when things are crazy, no, I'm not wearing a red shirt, and there's a reason for it. It's because, believe it or not, despite all of the craziness going on with the sun, we're not going to see much at Earth. We haven't been seeing all that much at Earth. We've been getting hit by big radio blackouts. But to be honest, they're not all that impactful. So I will talk a bit more about that as time goes on here. But we don't have any big solar storms on the way, and no kill shots, okay? So don't worry about it. Everybody who's stressing out, worrying that the sun's doing something crazy, deep breath. Everything's okay, okay? All right, so let me get the chat off here. Yes, crazy times, as Bill says. I will crazy train. Everybody's on board. Good. Let me change here and get rid of the chat so we can get going. All right, thank you guys so much for coming in. And if you see either Mike Richardson or Jerry Ryan, they are moderators, and they will, you know, treat them well and be good here, because they will boot you if you're misbehaving. But also, if you are asking real questions and I'm not seeing them, they will also promote your question if I've not seen it. So make sure you know, are kind to them, and if you see them, give them a shout out. Okay, so let's get started. As we take a look at the Earth-facing disk, all of the activity, you just saw it right here, all of the activity is due to region 3663. This is the region that started everything off, and if you notice right here, okay, keep this in mind, exactly where 3663 is right now. Okay, that was on the 3rd, right? It's almost center disk, and that will become very important when I talk about hot longitudes. Okay, so a longitude on the sun is a vertical line, right, that goes straight down. Remember this longitude, because there's another player that once it crosses here, starts acting up, and that's what we're going to have to be paying attention to as time goes on. Once you'll see in a few days. Okay, you'll see at the end of this briefing as the sun rotates through the current day, because we're sitting here at 5-3. Okay, so you saw a big flare right there. I am probably not going to remember all the flares, you know, types and what numbers they are and all that kind of stuff, because there's just been so many. But we'll talk a little bit more about that when I move on to the HF impacts. Right now I'm going to focus on solar storm launches. Now there have been a ton of them. Remember, we are at solar maximum. We're in the solar maximum phase. And so what we end up getting is about 8 solar storm launches a day. Not all of them are Earth-directed, thankfully. We would be going crazy if they were. In fact, basically none of them have been Earth-directed, but I will talk about the ones that are grazing blows, okay? So as we take a look at this, did you see a little bit of this fussing around in here? Yeah, well, look for something that looks like a horseshoe in this region, and we'll start talking about some of these launches that come in here, that these are the ones that we're going to be watching for. You'll see, I think that's where I started off too. As a matter of fact, right here on, let's see, TikTok, there it is. Did you see that right there, that kind of dimming region? Well, that happened late on the 3rd, you can see, and if we pull up our coronagraphs, you can see right here, you see this little halo? It's kind of hard. Let me back it up just a smidge. Can you see it right here? So there's the bright halo. As it begins to play, it kind of widens a little bit. This one doesn't look like it's quite large enough to be, something that we would consider, it is a partial halo, but it may not be something that was going to give Earth a real impact. So this one is mainly going to go off to the east of Earth and a little bit to the north. So this one is one that we expect to graze us or miss us by just barely, starting around, I don't know, maybe in a few hours. So we'll see. We might get a little bit of a bumpy ride from that one, but it's not going to be all that much. Now let's move forward. Where's the next one? I believe it's going to be a northward hit. Did you see that kind of bumpy little flare there? All right, here we go again. Funny thing is that region 3663, after about the third, when it fired off its first X-class flare that actually had a really good radio burst, and it had radio bursts that went up to like 450 megahertz. I actually posted that a bit on Twitter. It, since then, has not really given us much in the way of radio bursts at high frequencies. It's kind of like fizzled out. And sadly, you'll see that with some of these solar storm launches. In fact, as you take a look at this one here, watch this little solar storm. Look at this little thing. What is that? This was a big flare? What? So that was a little bit of something. You can actually see the full halo comes out this way. And so you actually have a little bit of a shock wave that's going with it, because the solar storms that this region's launching are large, but they're not, they're fast, but they're not large. So not a lot of material, but fast, so you see a big blast wave in front of it. This one, once again, is going to be grazing us likely to the north, slightly to the northeast. Is that right? Northwest. Hold on. I'm just making sure that someone isn't texting me. Okay. No. Oh, we're getting more solar flares. Okay. I have little alerts that go off. Okay. So this is that second one. Once again, another glancing blow. So we have one that's going off to the east of Earth. This one's going off to the north, kind of to the north, mainly just to the north, not really even the northeast or west. It's pretty balanced here. So another, poor aim when it comes to the sun. And then we get another one. I'm trying to remember which one this is. That might be this one here. Now, this is the one, we look at region 3664 and region 3668. There is a bunch of junk. If you've seen the actual sunspot regions, it's a cluster of stuff that's just nasty looking. But what that does sometimes is it means that things don't come off the sun in a nice coherent package. They kind of come off in like a spill of stuff. And I think that's what's going to happen here. You're going to see on the 4th, is this right? We'll watch for it here. Come on, show it to me. There we go. Hard to see. There's the woof right there. Did you see all of this? I'll back it up a little bit. I'll show a difference image here in a sec that'll actually help it out. But watch it brighten in this region here, okay? It'll brighten along this lower edge here, plus it will brighten in here, and you'll see some tufts coming off, and then you'll see something come off down here. So let me play it forward again. Watch it, see it brighten. See all that stuff and then stuff there, okay? And you saw stuff there. Well, this thing gave us yet another partial halo, right? You'll see it right there a little bit. It comes out a little bit further, and it's a little bit wider. If I let it go a little bit further, it's a little bit wider than the other one. So this is the one that I'm thinking, well, maybe it has a chance. Plus, I'll show you in a second a difference image that really kind of shows the fuller extent of it. And you'll see it came down in here and a little bit up in here. So this one has a much better chance of actually giving Earth some kind of impact, because as you can see, it's kind of in the Earth's strike zone. Their strike zone for solar storms is about a 60-degree cone all the way around the sun here. Okay, so this is sitting in the Earth strike zone, a little bit south of it, and most of the eruption looks like it's going to go to the east of Earth, but we might get a graze from this one. The sad thing to say, though, is that this one is the slowest of the bunch, because this one kind of just leaked off the sun. So are we expecting a big impact from it? Not really. So that's that one. And then, of course, this was a far side eruption. You'll see here, I'll show it to you in this difference image. It's just beautiful. As a matter of fact, I think it'll come up right now. Here we go. So here's the difference image of the sun from Subi, so you can see a lot more in the middle corona. In fact, I'll put Ed's thank you to this gentleman, and I'll put the link to his Twitter post. This was from a Twitter post he did. and you can see this eruption. See it right down here as I circle this whole region. So this is the active regions 3664 and 3668. But then you can see how much it actually involved a large part of the sun. All that right there. Whoops. Now let me go back a little bit because I'm going to focus on. I'll let you see it one more time. Let's go forward. Do you see it erupt like that? Now, what's cool is that, check this out. Just afterwards, what a beauty of a prominence eruption from the sun's far side. Isn't that gorgeous? So that's something that we don't see in the SDO, but we definitely saw it in the SUVI imagery. And of course, that one is not going to impact us, but it lets you know how many solar storms are being launched off the sun at the same time. So we counted 3, right? We've counted 3 that are partially Earth-directed, okay? And now we're going to get back to this one. Boom! Did you see that? This was the big X-class flare. This was the X4.5 flare, if I recall, right? This is an X4.5. I'm checking the date and time, 6:45-ish. Back up a little. Oop, boop. Nice little paparazzi bulb. See that? Yeah, so this was the big X4.5 flare, and you'd think with an X4.5, oh my goodness, we're going to get something monstrous, right? This poor region, it's so done. Look at this thing. What is that? I mean, come on. This is why I always say to people when they say, oh, we have a big X-class CME coming toward Earth. And I start laughing. I go, no, 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 no. You can't do that. A flare is an X-class or an M-class or a C-class or even lower. But that doesn't mean the storm that it launches, the CME that it launches, is some big thing. Look at this. This is about as wimpy as you can get. If anybody told me that this poor thing was from an X4.5, I'd just go, you're kidding, right? So this poor thing, he's tired. He's just got nothing left to give. So I wouldn't be surprised if this thing continues to fire off big flares on the sun's far side with absolutely no solar storm launches whatsoever, because it's hardly launching solar storms as it is. It just doesn't have any more ammo in the barrel. So again, another solar storm launch, another big flare, and it's not going to hit us. Okay, this one, if anything, is really not going to hit us. So that's how that goes. Now, you'd think at this point that we'd be able to calm down, right? And everything would be, if as soon as this region rotates to the sun's far side, we don't have any big radiation storms. Even with an X4.5, we haven't seen radiation storms. So even though SWIPC has its risk up for radiation storms, I'm not going to be looking to this region to give them to us if we get them. Okay, even though this one's rotating to the west limb. And I've looked recently with the big solar flares, and especially that big X4.5, nothing at higher frequencies. So we're not impacting satellite frequencies at all. Not even the L band, not up to the K band, nothing. So basically anyone who's worried about the Starliner, don't worry about it. All the the SpaceX stuff, don't worry about it. Everything's good. The NASA launches, don't worry about them. They're fine. We're really not getting anything that should make be something that would make a launch be a bad hold for a long time. But now that being said, that's talking about this player. Remember what I first talked about when we first talked about it, when it was right here? Region 3663 was sitting right here, and I said watch out for hot longitudes, right? Because that's about when it first started firing the big flares. Look who's at that hot longitude now, right? This bad boy. And guess what? I am staring right now, it's not in here, but I am staring right now at a double flare that looks like it peaked around an M4, 4.1 or something, close to that, and then it peaked again at an M26. So we had almost an R2 level radio blackout, and then another one. These, I believe, are coming from 3664. The reason why, it's reached that same longitude at which caused region 3663 to light up. Okay, so we may be chasing this all the way across the disk, just like we chased region 3663. So, big flares, even when this one rotates to the sun's far side, we may not be done with them because it looks like it's region 3664's turn, and then possibly region 3668's turn as it rotates to this longitude. and they continue because region 3663 has demonstrated that it was active all the way across the disk. So radio blackouts may still be very much on the menu, okay? So realize that. This is definitely the week for solar flares, and we're not done even then because, do you guys see, let me back it up just a smidge. Do you guys see the brightness back here? See a little bit of the brightness. This one is from a region that's just beginning to rotate into Earth view, but you see some brightness there? Yeah. Has anyone been paying attention to the far side? Well, we have some fun coming. Yikes. So this is our JSOC HMI helioseismology far-sighted viewer. And if you guys remember, and I can hardly read these numbers, they're so small. I tried to make them big, but I just didn't have time to, you know, there's so many. If I made them too big, they'd get they'd run all over each other. So these are active regions from the last rotation. Okay, this is our helioseismology far-sighted viewer because we don't have stereo A anymore, being able to show us the front or the far side of the sun. Stereo A is staring at the same side of the sun that we're staring at. So we have to resort to helioseismology sounding of the far side to get an idea of what might be lurking there. And the regions that you see here in gray, this is from the front side, the last time these regions were in view. And we had a lot of activity, especially from region 30. Oh my goodness, can I see this? Let's see. From region 3645, that was a big player. We had also region 3638, that became a big player. 3654, as well as 639 and 3648, okay? All of these were very big players. Actually, I think 3639 was not, but it was a very large cluster of spots. And so all of that was on the far side, you know, or it was been on the far side, and it's going to be, as you can see, as I start moving this to the yellow, you see how these regions now are jumping into the yellow. Anytime you see dark stuff, that means that region is surviving its far side passage. So look at all of the dark regions on the far side. Yuck. We got a lot of junk. So it does look like at least 3645 and 3640, what is that, 47 and 58 are surviving. In also region 3654, and these regions up in here, 44, 48, these, like I said, are big flare players from the last rotation, and look how close they are. Okay, so this is a current image from today. So you've got a lot of dark regions on the far side that are about to rotate into Earth view. This will be about maybe 5 days from now. Okay, we even have a little bit of something that's rotating into Earth view right now. That's this puppy right here. Okay, and what this kind of halo looking stuff, this brightness over here, that could very well be the beginning of this from region 3638. It's kind of hard to tell yet. So we will be watching to see if we're going to be seeing lots of limb events. If so, that's from all of these regions back here. Okay, but they're also very big, so don't expect that as the activity on the front side begins to settle down that we're going to get a break anymore. It looks like we're not going to get a break. In fact, the only break we may get is actually in about maybe 3 weeks, 2 to 3 weeks from now, okay? Because looks like there's a little bit of a dead region here, but a lot can change in a very short period of time. So just realize that we are going to be getting a lot of solar flare activity and possibly solar storm activity here over the next easily 2 weeks, okay, before things move on. Okay, and with that, let's take a look at the geochron. Okay. Now, a lot of you, and I don't know where I'm going to stand here because there's so much going on. A lot of you guys already know what the geochron is. For those who are in my Patreon family, you guys are very familiar with this. This is a timepiece that has lots of features. You're seeing, in this case, obviously it's a map of the world, but you're seeing features of precipitation and cloud cover. But what you're also seeing is amateur radio contacts. For those of you who have the geochron or can read the legend down here, you know what bands they're on. And what I've got are space weather layers, and no, sadly you can't get these from the geochron yet. I'm developing the layers, the space weather layers for the geochron, so you have to bear with it while I continue working on them. But as I develop them, you can see how useful they can be. So what you're about to see are basically the big solar flares over just the 5th. Okay, so here's the end of the May 4th. You see here, this is May 4th. Here's the UTC time. And what I've got down here is a plot of solar flares. This starting here is around the 5th, I believe. These are like 3 days, the 3rd, 4th, and 5th, I believe. And so I made this yesterday, so it doesn't have all the flares on it, but forgive me. These are some of the big flares from just from the 5th. It doesn't count the big X 4.5, but we'll get to that in a minute. I just want to be able to show you how the impacts are really affecting the HF and VHF bands. So as I try to get out of the way, I'm not sure how I'm going to disappear for a second so you can see this. I have, as soon as it happens, look, so here is one of the first flares. This flare is the M, what is it? This is an M9.1 flare. And if you notice, all those radio contacts that you saw, notice how they clear out. See that? And that, if you want to see on the X-ray flux, that was this flare here. Okay, so it was just beginning almost right on May 5th. It was right at the border of May 4th to 5th. This was late on the 4th, 2351 UTC. And as you can see, so it hit the Pacific region, somewhat a part of the Asian Pacific as well. Australia felt it, but you know, most of the regions that were in the dark side didn't have any issue. But we move on. And as that one disappears, we'll hit the next big flare, which is just a few hours later. And I'm just going to let this run until we get the flare. There it is. Boom, right there. That was an M8.4 flare, so you can see the X-ray flux right there. And once again, look at this. In this case, the Asian Pacific really got decimated. You don't have much, even in the Pacific near the Hawaiian Islands. You just don't see all that much when it comes to radio contacts. These have been big flares and really have lit up the ionosphere quite significantly. But again, we're not seeing, at least recently, we're not seeing the radio band, I mean the higher level radio bands, meaning the satellite, like UHF frequencies. So satellite operators, you should be feeling maybe nervous, but at least reasonably okay. Then we had a big flare. I think we had several really big flares. The next one is, I believe it's an X-class flare. We'll wait and see. Bear with me. I should have fast forwarded this a little bit maybe, but it's coming. I know it's coming. These are little flares. There we go. There's a big one right there. This was an X 1.3 flare. And my timing is slightly off on this one. This should be a little bit more red. If you look, you can actually see the timing of my flares down here in blue compared to the time on the UTC clock. I'm still trying to get those things toggled together. It's a challenge making space weather layers for this thing. But as you can see, we did get some clearing out. And again, this was a reasonably large X flare. It wasn't as big as the X 4.5, which we'll see later. But these are all from region 3663, and as time goes on, you're not seeing as much. You're not seeing long duration flares. They're not lasting too long. They're impacting radio communications for a short while, but not too long. So the next one we're going to hit, this one actually affected Africa pretty significantly. You can see, it'll stop right there. Oh, let me back up just a smidge. Sorry about that. So this was an M7.4 flare, and you can actually see he did clear out some of the contacts there in the African area. And I think I have one more, don't I? I'm not sure. I think I do. So we'll wait to see one more. Here's the bigger one, I believe. So this is yet another X 1.3 flare, and this really cleared out a lot of stuff. Sadly, shortly thereafter, I had a data gap that decimated, really took out the contacts. And the funny thing is, I keep having anyone who uses PSK Reporter or some of these other repositories for ham radio contacts, has anyone else noticed that when there are big flares that the reporting stops for a short while? I keep noticing that quite frequently with the geochron, and I'm not exactly sure what that is and why that should be occurring. I don't want to call it saying it's a solar flare issue, but it's something that I find happening more often than I'd like to admit. Okay, and I don't know if I'm just kind of letting it go for the rest of this day. Oh, we had one more? I thought that was it. Maybe I'm just letting it go for fun because it's so pretty. Yeah, I think I am. Okay, now let's flip to the big X 4.5 flare. So I will stand out of the way here because in this case I'm using G7IZU's map, and you'll see contacts here. You can actually see the band structure here. So you can tell what frequency. And if you look, oh, I can't see it. Where is it? I think you'll see a little yellow dot that goes across. That's noon. But I'll basically highlight where the solar flare impact would be. Here you'll see that shortly. So let's play that. So this was today's X 4.5 flare, which you'll see lighting up right now. Oh, and that did not, oh shoot. It didn't take my new version of the thing. Okay, so here's the X 4.5 flare. Sorry, I actually had a newer version than this, where this oval was spread out a bit more, because here's noon. And you actually, if I go back a little bit, I'm going to go back just a smidge. This is why I'm kind of upset that this oval needs to be further out, because I have contacts in here which disappear. So let me back up just a smidge. Look at all these contacts right here, yeah. Look at all these contacts in this region, right? So this whole area is being affected. Let me play it forward, and you'll watch not just in here, but also in here. You can see them dying out a little bit during that big solar flare. See, look at that. Look how few there are. And you can even see that some of them were actually shorter throws. It was pretty amazing, pretty impactful. So I may post something like this on Twitter, the corrected version I'll post on Twitter so you guys can see this from the X 4.5. But again, as I looked at this solar flare at higher frequencies, nothing. So I don't think Starliner is going to be an issue. You know, we shouldn't be seeing any communications problems with that. Okay, so that's all the flares for now, but remember region 36, what is it, 36, I forget the number now. Hold on one sec. Let me grab the synoptic chart. I don't want to tell you the wrong number. 3664, okay, good. It was region 3664. That's going to be the player to watch as the region, that 3663 begins to rotate to the sun's west limb. Okay, so let's talk a little bit about that one solar storm. Remember, there's 3 solar storms, but I showed you one that I said, well, this one looks like it could possibly be Earth-directed. Well, the Space Weather Prediction Center agrees with that, and they actually modeled this particular event. I'm not sure why this... Oh, boy, I sure have lots of problems with my... That's too bad. I didn't notice this. Okay. Hold on a second. What are you doing? Oh, okay. It didn't mess up. I just had a delay. Okay. So we're taking a look at our solar storm prediction model. This is NOAA's version of the model. The top panel's density, the bottom panel's velocity, and you're looking down at the sun from the North Pole with Earth being off to the right. And as I set this solar storm model in motion, remember that solar storm launched basically a little bit to the east of Earth, but also a little bit south. So that's what you're seeing. You're seeing it moving slightly to the east, and you're seeing it moving slightly south. But as it moves, you can see it's not very fast, this solar storm isn't. It's just kind of a wispy thing. And it's not, you know, directed directly at us. We're going to get a flanking blow from this. I think there's a chance that we'll get a little bit more of a blow than what the Space Weather Prediction Center says. They're showing it being very, very mild. But impact will be around 4 UTC on the 8th. I think there's a chance, I've seen with some of the other solar storm grazing blows, some of them come as late as the 9th. So I'm expecting that we're going to see storming from this, probably more high latitude than mid latitudes. But anywhere between the 7th and the 9th, we're going to be having kind of just a bumpy ride. And this is probably going to be the peak of it here, will be sometime on the 8th, possibly into the 9th. And so that will be reflected in my 5-day outlooks. So Aurora photographers, if you're at high latitude, you definitely could get a chase. I don't really know about mid-latitudes. It's kind of hard to say. But we've been underestimating the impact of these solar storms for a while. So I'm a little bit shy to say, oh, don't worry about it. I think Solar Cycle 24 conditioned me far too much. All right, now, switching to our moon, we are now passing through the new moon phase, with the new moon being on the 8th. And I believe by the 11th, the moon will be about 14% illuminated. So you night sky watchers, if you want to catch those dim objects in the sky, like some aurora, you know, this little companion is not going to be all that bright for you. So it should be a good time, just as long as we have bright enough aurora for you. So at least we won't have the moon wash it out. So then we're going to move here in just a moment to our 5-day outlooks. As we switch to our solar storm conditions and aurora possibilities over the coming week, at high latitudes, we're dealing with wind, fast solar wind right now. It's not all that fast, but it's sitting at about 500 kilometers a second. We've got basically unsettled conditions, but we do have about a 25% chance of a minor storm at high latitudes. You're going to see a big spread between what we expect and what we possibly could get throughout this forecast, simply because we have so many glancing blows that we're worried about hitting us, and we don't really know if they're going to hit us. We haven't had all that great of coronagraph data either recently, just due to a little glitch. You know, real-time data is hard. So when we have lots of stuff going on, it's kind of hard to stay on top of it. Okay, so when we get these solar storms coming at high latitudes, NOAA's expecting active conditions, but we do have up to about a 35 to 40% chance of a major storm. I think that this is a pretty good estimation. I might have actually bumped this up to minor storm conditions, but again, we'll have to see. So aurora photographers, if you're at high latitudes, just stay on your toes on the 8th and the 9th, okay? By about the 10th, things should be settling back down, unless, of course, we get another solar storm launch. So don't trust this forecast too far out to the right, because we have a lot of activity on the sun, and you're already seeing region 35 or 3664 beginning to show signs of solar flares, which means possibly more solar storm launches. So let's see if we can get this to go to, come on, I have to wait for it, sadly. I didn't put this, okay, mid-latitudes. Switching to our mid-latitudes, we are still expecting that fast solar wind, but NOAA's giving us about a 30% chance of active conditions. That is on the 7th. Again, we have a storm watch for the 8th and the 9th, but only expecting unsettled conditions. We do have about a 20% chance of a minor storm. I believe I bumped that up a little bit from NOAA, just because I believe that we've been underestimating so many of these storms lately that I just don't want to make it seem like there's no chance at all. But as you can see, there's a big discrepancy between what we expect and what could happen. So again, aurora photographers, if you're at mid-latitudes, keep batteries charged, you know, just stay on standby. You know, check your phone every now and again, check your apps, make sure your apps are on if you want to go chasing, because it may surprise us and give us something good. Then after that, we expect unsettled conditions and as we move into the 10th, and then almost quiet conditions by the time we roll into the weekend. Again, unless something else changes when it comes to, you know, all these new active regions that have rotated not just into Earth view, but also into the Earth strike zone. And so that will be that. And hopefully, I'm sorry I didn't put a little, there we go. Okay. Now switching to our solar flare and Dayside radio blackout outlook over the coming week. We are sitting at about 174 solar flux. This is likely going to rise just a little bit, especially as region 3664 begins to take center stage. It may dip a little bit as we move into the weekend because region 3663 is rotating to the sun's far side. But remember all of those dark regions I showed that are on the sun's far side that are just itching to enter into Earth view. Those regions will be rotating into Earth view right about the weekend. So expect that solar flux will then rise again, and along with it, there's a very good chance that the X-ray flux will, the risk for big flares will as well. Right now, we're sitting at moderate noise on the bands. NOAA's giving us about a 90% chance of M-class flares at the R1 to R2 level easily over the next 3 days. As region 3663 rotates to the sun's far side, that may dip down to about 75%, but it all depends upon what region 3664 does. So, you know, expect a lot of, once again, we get out to the right in these forecasts, expect a lot of change very quickly. In fact, we're expecting about a 50% chance of X-class flares, that's at the R3 level radio blackout, easily over the next 3 days. And again, dropping down if region 3664 continues to behave itself, but we shall see because it's already giving us M-class flares. So again, moderate noise will be the thing, the conditions we're just going to have to live with for a while. So amateur radio operators and emergency responders, expect the bands to be an issue for you on Earth's day side for the foreseeable future, sadly. Now, as we switch to our radiation storm and polar aviation outlook over the coming week, we are sitting at the D1 normal range. This is at flight level 360 for you aviators. This is also the S0 quiet range for everyone else. We do not have radiation storms right now. It is okay to fly if you're a high-risk passenger. We don't have any issues there. We do have about a 25% chance of an S1 to S2 radiation storm over the next 3 days. Likely that is a bit overestimating because region 3663 just looks like it's petering out. However, if region 3664 takes over, all bets are off. This could very well be the risk as time goes on. But if everything stays quiet, then things will continue and will begin to die down when it comes to radiation storms, at least just a little bit, until some of these other regions rotate to the sun's west limb. And you'll see it rise again as we move into the weekend and possibly into next week. But outside of that, you pilots definitely check the ICAO advisories, because we are dealing with these big radio blackouts, and that can cause you issues for communication and possibly navigation just a little bit, especially if you're in the smaller planes. And if you're a drone flyer, definitely stay vigilant near dawn and near dusk, because that could be a real issue for you. And so that's about it when it comes to the big solar storms and solar flares, all of this crazy antics that the sun has given us. Again, I'm wearing a blue shirt. It's not a red shirt, so don't worry about big, huge storms coming from the sun right now. Right now, we're still pretty much calm. So with that, I will pause and answer some questions, and then we can go into a deep dive if you guys want to look. I will show you really quick. Well, I'll show you in a little bit. Some people have asked me about Twitter, about some of the Aurora pictures. We actually do have some Aurora, and I can share some with you from some field reporters that have been reporting on Twitter, and they're very beautiful. So we hopefully will get some more pictures like that from the storms that are coming. Oh, wonderful, Jerry. Good to see you. I'm glad both you and Mike are on here. Great, great, great. I see you guys answering questions. So, okay, guys, that's it for the BLUF. So I will start looking at the questions. Let me switch to the show the chat right now. Oh, okay. I made it through. It was a lot of stuff. Okay. Let's see, guys. Do we have questions? Will noctilucent clouds be in space again this year due to solar maximum? Sure. As we get into summertime, noctilucents will definitely be part of the picture. To what degree, I don't really know, because our sun is it's been changing, and it's definitely a stronger cycle than we had last time. So that will be a fun thing to watch unfold as we move through solar max. How that affects noctilucent clouds through the summer. Good sunny eclipses. Thanks, Doc. All good info. You're very welcome. Great, Jim, and I love that. Wonderful. Thank you. Oh, there's a shirt code. Ray Dreamer, there wasn't a shirt code until somebody in the chat, or not in the chat, but I think in the comments one time said to me, "Oh, I knew there was something big. As soon as I saw you wear red, I knew there was something going on." And I went, "Wait, do I wear red subconsciously?" And I put red on anytime there's something big going on in the sun. I went, I wonder if I do that, and I don't even realize I do that. So now I'm very conscious about it. Somebody told me that, like a year or so ago, maybe longer than that. So now I'm very conscious about it, that if I don't want to scare anybody, I don't wear red. But if it's a fun time, like big Aurora shows are possible, or big solar storms coming, I'll put red on, and let people get excited about it. So yes, there's an informal shirt code that I'll see if I can continue it if you guys like it. Oh, okay. Slightly off topic, but what are your thoughts on the recent news about human space debris and dust accumulating and impacting Earth's magnetic field? Well, it's not really going to impact Earth's magnetic field. Earth's magnetic field doesn't care. But space debris is a real problem for us. Space traffic and management, we're kind of teasing that it's becoming like orbital Tetris. Because you're having to shift all these space, you have to pivot them up and let something go by and go back down, and just to make sure that your orbits now look like this, because you're dodging and weaving so much. These guys are going to be pulled over for DUIs in space because there's just so much weaving. But I mean, we've got to get on top of the traffic management, and obviously, especially in LEO, we do not want collisions up there. It is not easy to sweep things out of space. There are a lot of people that have worked on things like membranes and things like that, these spacecraft that are kind of like blankets that they then wrap around debris and then fall back and burn up in reentry. Those are not as easy as one might think, because the type of radiation in space is such that really, really thin membranes, like really thin that they want to do, those shred. They just literally shred and fall apart very quickly in the radiation environment. Thin materials don't do well. So there's challenges there, material challenges. So, but that's for a different time. That's a good question, though. Arnold Schmidt says, hi, now that you've just stated that there's no, I missed it. Shoot, I missed it. Missed it. It scrolled by too quick. Sorry about that. Okay. Say we have a week over average solar flares. Will my sunburn be worse than normal? No. 21, whatever your name was. So I missed that too. It scrolled off the top. No, you will not have to worry about that. Our atmosphere protects us from all of the harmful rays. Now, if you were out in space, sure, right? If you didn't have protective gear on, sure, because the extreme ultraviolet out there is very damaging, as well as the X-rays and the gamma rays and all that kind of stuff. But our atmosphere shields us from that. So you don't have to worry about it. But that's one of the reasons why our sun looks so crazy, like the sun I'm standing in front of, looks so crazy in space-based telescopes compared to ground-based, is because all this stuff, this is EUV, extreme ultraviolet, you can't see this at the ground. That's why our sun looks so different from space than it does from the ground when you use the right types of telescopes. It's not CGI, I promise. It's just our atmosphere. I wish, it'd be so cool if it were CGI and that kind of conspiracy was real, but sadly it's boring. The truth is boring. It's just our atmosphere. That's it. People want desperately for the sky to fall. I don't get it. I agree. Luckily, if you have been trolling around YouTube and seeing people talk about the nightmare of flares that we have, don't believe it. In fact, let me switch very quickly, because there's something very important that you guys should know about. And one of my, here, I'm going to do this one. And one of my colleagues on Twitter posted a really great thread. Oh, here's one of the Aurora photos, by the way. Let's see, I had it up for a while, pinned to my, if I can find it. Sorry if I make you dizzy. Isn't it here? We had Aurora clear down in Germany. Oh, there we go. Oh, good. I thought I had passed it. Make it bigger. So this is a tweet from Dr. Ryan French, and it's a long thread, so you can go peruse it at your leisure. But one of the things that he was reminding people was that in the cycle 24. We actually had recalibrated the GOES spacecraft, especially the X-ray fluxes. And so the big flares that we had in cycle 24 were actually underestimated. So we actually, when you compare cycle 24 and cycle 25, we have so many X flares now, and it's like, oh my gosh, what's happening? The end of the world is coming. No. It's just that during cycle 24, we had calibrated X flares in a particular way because we had gotten really cool instruments when we got the GOES-R block. We had gotten GOES 16 and 17 up, and their instruments were just orders of magnitude better than what we had had prior. And so at that time, a recalibration was done. Well, we had thought, or at least the community had thought, that the calibration that was being done was bettering, was doing the right thing. As it turned out, that calibration was making all of the flares that were being recorded to be underestimated. So last cycle, we had very few big X-class flares. We should have had more. And the reason why was we were underestimating them by a lot. So if you read Ryan French's, sorry about that, if you hear the big helicopter go by. If you read Ryan French's post here on Twitter, and I'll click in it here so that you can, it's on my feed, it's not very far down. But as you can see, he goes over and over talking about, get out of the way, talking about all of the different blocks, all of the different GOES in their timelines over the course from basically 1975 all the way up to current time. You can see how many different GOES spacecraft there were. We have to intercalibrate all of these instruments so that we have a long period, an unbroken database of solar flares that we can look to. And when we intercalibrate them, sometimes we make adjustments, and then we go back through the database and we readjust everything else. Well, it turned out that there was an adjustment we made that we decided to, in a sense, renege on and go back to the original. And what that did is that affected some data, especially in cycle 24, which everybody's trying to compare with cycle 25. And it's like, don't do that right now. Unless you know what flare database you're using, don't do that. Because what you're going to do is you're going to think that solar cycle 24 was like super, super sleepy, and solar cycle 25 is this huge monster. And it's like, no, it's really not. Both cycles, cycle 24 and cycle 25, are underperforming compared to even the average, the median cycle, okay? So Dr. French goes through this, or Ryan, if you're his friend, goes through this in great detail, as you can see, and then he even has a few people that are commenting about it. But it's a really useful thing to look at and take into consideration, especially when there's so many people out there right now who are trying to make solar cycle 25 into this planet killer. It's really not. Okay, and so sadly the data is misleading, and it can be misused in such a way that it ends up really kind of feeding the fear, right? Feeding the fear that we don't need. So if you're not on Twitter or X, you know, you can find it on my Patreon feed if you are a member of my Patreon family. We have a chat that goes on in our Patreon family. So if you're a member there, you can find it as well, because I talk about that stuff in more detail there. Okay, questions, more questions? You're a great teacher. Thank you, David. I appreciate that. Strong enough flare will deorbit Starlink due to atmospheric drag increases. Cipher 9, you are absolutely right. Because it's not really the solar, the solar flare does increase drag a little bit, but it's really the geomagnetic storm from the big solar storms that hit Earth. Those are the ones that can deorbit the spacecraft. The solar flares themselves, that's just a momentary burst of light. But a solar storm that's also launched, when it hits Earth, it causes a reaction that actually heats the Earth's upper atmosphere through all of the interactions that go on in the particle deposition and aurora. Even this stuff heats the Earth's atmosphere. And as it does all that, it causes circulations and all these things that occur that inflate that atmosphere, and that's really what causes, over the course of a day or two, or possibly 3, or if there's multiple solar storms, possibly a week. And that is what really causes these spacecraft to deorbit, because it's just over a long period of time. A single solar flare that lasts, minutes to hours, not really going to do that much. But the big solar storm sure will. Okay. So what I'm hearing is that we're now grading flares on a curve. That's great. Yeah, that's a great way to look at it. Oh, gosh, I don't know. It depends upon the teacher, right? Who's grading? Yeah, I hope I get an easy grader. I guess we have to say that. We had a hard grader in cycle 24, and in cycle 25 it's an easy grader. So everybody's getting a higher score. So that's pretty funny. Yeah, it's a fun way of looking at it. Yeah, Black Hawk helicopter. I sure hope not. Not flying over my house. That's funny, Marcelo, though. Let's see. Steffi B. Space weather science is still wet behind the ears. Yes, as they say. We want more changes and updates as we will see more changes and updates as we learn more. Yes, and it's still very much a fly by the seat of your pants kind of field. We're very much still in the wild, wild west phase. I've oftentimes likened it to the terrestrial weather back in the 1950s, right, when we had very little more than, let's say, a tornado siren to go by, because we just don't have that much instrumentation. We don't have that much in terms of data. Sometimes we have, if an instrument breaks, it's a single point failure. And so we have no data. Like, for instance, when we were having issues with Soho Lasco, there was just like a timing glitch. And that can take data offline, and now we're blind. We have no coronagraph that we can really look at other than stereo beacon data. And it wasn't from Earth, wasn't from the Earth's perspective. I mean, we're literally in the baling wire and bubblegum phase of space weather, where if something breaks, I mean, we are just bandaging things together and going from piece to piece to piece, just keeping the thing operational. So as this infant field, this field that it's in its infancy continues to grow, it will become more robust. But I think people sometimes forget that, and they believe that space weather is as robust a field as terrestrial weather. And we so are not. Remember terrestrial weather back in the 1950s. I mean, we didn't have satellites looking down. I mean, people didn't know anything, really. So, you know, be gentle with us. And this is part of the reason why space weather information is so easily misconstrued and so easily taken the wrong way, and people run with it when really you can't look at it a certain way. You have to be very, very aware of all the bits and pieces and all the things that are going into something, and all the recalibrations and all the changes in instruments and every little bit and piece that goes into, especially when it comes to operational space weather, because you're dealing with data that is not clean, that's oftentimes filled with a ton of artifacts, that is not what we call science grade. This is oftentimes why scientists don't like publishing data until they've got it cleaned up, is because people will take this rough data and they'll pull out different aspects of it and go, ooh, look, there's an alien. Ooh, look, there's a big spaceship. Ooh, look, there's a big solar storm. And it's like, no, that's a data glitch. That went into safe mode. What are you talking about? There's housekeeping data you're looking at. You know, it gets it can get pretty bad at times. And yeah. And NASA and NOAA, you know, and all the space agencies try to be open and transparent with their data. That's why there's so much data out there. The problem is that we don't have a lot of scientists in the loop that can disseminate the data. They're all just trying to write papers and move the field forward. So there's a lot more data than we have expert eyes to share with the public, and that causes a big chasm, you know, that is really hard to breach. But that's what we're trying to do, actually, as I'm training meteorologists. That's exactly the chasm I'm trying to fill it with experts, you know, that then can do that job, so, and help everyone, including me. What do I think of the connections on intensified solar activity in these bunching jet streams and river from the sky from the floods happening across the planet at the same time? That is way too complicated a question, and it looks like it's moving into meteorology. I'm not aware of what's going on in meteorology right now because the sun is so active, so I am not paying attention to what is going on with terrestrial weather at the moment. As far as space weather affecting things like polar vortices and jet streams, yes, it does. There are people that are working on that in mainstream science. In fact, even Hamsai and Nathaniel Frizzell, that was one of his papers that he did as a graduate student, was talking about how space weather is affecting, like geomagnetic storms can affect the polar vortex. The coupling between the neutral atmosphere and the charged atmosphere, which really is the boundary between space weather and terrestrial weather, that is slowly but surely being filled by people who are cross-disciplinary. But it is such a tough field, and there's so few people to do it, and there's not a lot of funding as of yet, but it's coming. So, you know, if you're a fringe scientist, it sounds like you might be a fringe scientist, keep working, keep making those connections, keep raising awareness of stuff like that, because eventually mainstream scientists will be able to get funding to dig deeper into some of these things, and you know, and we'll start bringing these two fields together better than we have. Yeah, and again, that's one of the reasons why I train meteorologists, is for the same reason. So I'm trying to get these fields to be bridged, because there's so much, they affect so much, both coupling from the neutral atmosphere up and from space weather down. They both happen. Okay. Marcella, what is happening? I don't know. I didn't see your question. So, let's see. Bessar says, do you ever get a chance to weigh in on the future direction for new observatory hardware? No, you know, I do. We have decadal surveys. We have missions. When I review proposals, yes, I do weigh in on it. As a matter of fact, just last year I weighed in on some big ones. I'm not going to really talk about them though, but I weighed in on some big ones for one of the NSF big centers. We did well, and actually NASA centers too. I actually did. I forgot. I did a review for some big NASA centers as well. So yes, I do weigh in on those. But basically, people have to propose. So I will help. Look at different teams that have been proposed and help decide whether they'll be selected. But I'm just one of many people who do this type of thing. All of us scientists are asked to do this from time to time, especially if we write proposals for funding. We help the community out by volunteering to do that type of work. So the answer in short form is yes. Okay. The movie called The Knowing, is that possible? No. The Knowing knew nothing. It is not possible. The Knowing is actually something that I teach in my, I talk about in the Millersville classes, because it's a very there's a lot of teachable moments in there about what it isn't and what Hollywood tries to get us to swallow when it comes to space weather. But just look at it as you're being fed junk food by Hollywood. Okay, it's not healthy food when it comes to space weather. So set it down, set the burger down, go pick up a salad. Don't pay attention to that stuff, because it's really not true. Okay. Let's see. Funny, Texas Flash. Maybe, Amanda Lynn, you say maybe a scientist will read some of these comments and make a breakthrough connection for something. Yes, that's what I'm hoping fringe science can do. And a lot of, it's so funny too, some fringe scientists, which I absolutely adore, they actually get tired of being fringe, and they decide that they're going to go in and they go back to school, and they'll end up getting a PhD in the field. And it's so fun to see that, where people's interest in just as a hobby turns into something more specific. And someone I can think of who wasn't a fringe scientist, but just his casual interest in astrophotography has now led him to become an ionospheric physicist, and that's Vince Ledvina. Nathaniel Frizzell was the same way. He was just a ham radio operator, and his interest in all of it became so compelling for him that he became an ionospheric physicist as well. I just love that, because then you bring the best of both worlds in, and your view of science and of this field is different than someone who just went from straight through academia all the way up, because you've got a broader understanding and just a different perspective, kind of an orthogonal perspective. And I love that, because all fields need that. All fields need to have broader perspectives. I always say that mainstream science keeps fringe grounded, but fringe science gives mainstream science wings. And so it's like two different hands that shake, that need to be shaking with one another all the time. So if you decide to go into fringe, or you are a fringe scientist, consider getting a PhD in the field. Consider going and getting an advanced degree, or just even getting a degree in as an undergraduate, because it'll help you immensely. It'll get you to understand why mainstream scientists think the way they do, and it'll get you to be more rigorous in your assessments, in your analyses. There are good reasons to get skilled, to go through the academic process. Okay, let me check. It looks like we're kind of running out of questions. Let's check to see if there's anything on Patreon. If anybody posted something for a question. I'm glad that I've answered a lot of people's questions here. It makes me feel good, because I don't like it when I'm not seeing nearly as many people being frightened. So that makes me feel very happy. So definitely enjoy. Listen, we have any questions there. So definitely enjoy. If we get a little bit of activity, like I've said here, I still have the let's see how much. I'll just show you just a couple fun ones. So here's some Aurora. Where was this? No, I don't know. I just kind of retweeted it. Taken by MBV. Where is it? Oh, in the Netherlands. There we go. Sorry about that. So this is some gorgeous pillars in the Netherlands. That was just last night. Here's some, and this is in Ireland. So we had a little bit of faint Aurora in Ireland. This is from Michigan. You see the gorgeous pillars there. We had just a teeny tiny, but that was in Michigan, in Minnesota rather. Very little, and then it got brighter. Here's some in North Wales. Sadly, when this particular storm, it was really, really strong, and then, southward field, and then right when it started getting dark, or got close to get dark in the United States, or in the north, or in the Western Hemisphere, the field flipped north and almost completely shut off. And then we had to just wait for a little while, and then it finally flipped south again. So some people who were up late got a nice show. Others, oh well. We had some gorgeous stuff over Germany. Here's some beautiful, some purples. And I'll go back a little bit further. This is probably somewhere in, is this either, it's Cornwall. So a little bit, but very weak. Here's some in Kent, in southeast England. And yes, we are getting more Aurora, but remember, the cameras are so much better. So, and everybody knows, this is the Netherlands again, and everybody knows, we've got field reporters online, so they know when it's coming, far more than we did before. So this was in Rutland. Here's a very hasty back of the cam shot. I forget where this is. It's UK, somewhere in the UK. Oh, Dartmoor. That was in Dartmoor. And then here we go in central Austria. So we got really far south. I even looked at one of the webcams. I mean, that's when you know it's good. Here's southeast England under clouds. But here's how you know it's good, because this was me looking at a webcam, one of the many webcams that are out there. This was in the Austrian Alps, and seeing just, gorgeous green glow everywhere. And when you get to a point where you have a hard time distinguishing the difference between air glow and aurora, because the cameras are so sensitive that the whole skies light up, pretty soon we're not going to be able to take a nighttime picture without having the sky look like it's daylight, or having the sky covered in air glow. I think it's amazing that these cameras can be this sensitive, and especially even cell phone cams. But yeah, here's more. This is Tampere. This is Finland. And here's more from Germany. Look at this one. This is a great. This was on a picture in Germany, though. That's what made me go look for the webcam in Austria. And then this is in Kent. Isn't that a pretty back of the cam shot? So we've had some nice aurora over the last couple days. Here's James Rowley Hill. Some gorgeous pillars in Norfolk. Okay. But it's been kind of off and on. And it's going to continue to be like that. So again, in Germany. Oh, no, Netherlands. My fault. Netherlands. So we have a lot of pictures like that on the internet right now, on Twitter. And then if I go to, here's the solar wind. Mainly, most of it was from this region right here. So this was where we got a lot. And then, of course, like I said, it flipped north. This red line here, this is the magnetic field. Southward field is anything below this line. So anything below my hand here, that's all southward field. And that's what gives us aurora. And then as soon as it got to the United States, whoop, flips up this way. And anything above my hand in red, all that is northward field. So then we got a few little jumps here, where it went below the line again. So we got a few more times where we got a little bit more red. But now we've kind of just settled down. And this is why I said in the 5-day outlook that we're in the fast solar wind, because this is the solar wind speed. And we have picked up to above 500 kilometers a second. We're somewhere around 600 kilometers a second now, 550 or so. So we are in the fast wind stream right now. It might pick up just a tiny bit more, but I doubt it. It'll probably start waning just a little bit. And again, we probably will get a bit more of a bumpy ride. I don't know if we're going to see anything as large as this. It's hard to say, but we didn't expect much from this, and we got a bigger hit than we anticipated. So cycle 25 is definitely giving us more. It's not that cycle 25 isn't bigger than cycle 24. It is. It's just that these cycles still, even without all the activity, still nothing close to the average cycle. It's still underperforming when it comes to the average. Okay? So that's why the blue shirt. Okay, guys. Any final questions before I button up? I see, Dr. Tamitha, fringe science or not, would it be possible for you to briefly go over whether a magnetic pole shift is possible within our lifetimes, and if so, what the effects might be, in my opinion? I've said this so many times, actually, and I don't know. I might do a class on it. I have to talk with my moderators and my VIPs about this, as well as my Patreon mini course folks. The reason why I'm a little bit reluctant to do a pole shift mini course is simply because the chat will be rowdy, right? I mean, people are extremely, pardon the word, polarized when it comes to Earth's magnetic field flipping and whether it's doing that or not. Geophysicists have seen what we call excursions like this many times before. It's in the geological record. There have been many times the Earth's magnetic field has dipped like this and then recovered, and there was no flip. So I don't, as long as a geophysicist is not comfortable saying we are absolutely going through a dipole flip, I'm not comfortable saying it. I mean, it's their expertise. I know this much geophysics, right? I mean, I have it in my, I did study it because it is part of my degree, but I didn't study it like you know, people who are really studying it. I studied it because of planetary geophysics. So I might be enticed to do that, but it's really going to depend upon what my Patreon family, how they feel about it, and whether or not my moderators are willing to put the boxing gloves on and keep the chat at, you know, in line. And that's a tall ask, right? I mean, it's way tall, and I'm only this tall, and it's way up here. So we'll see. But when it comes to the how to deal with the pole flip, if we are having our dipole field component flipping, and it's just one component of a much larger field, okay? Just because the dipole part is flipping doesn't mean the magnetic field goes away of our Earth. In fact, you know this for a fact because the sun right now has no dipole field component. Its dipole field component is 0 right now. And yet there's still a magnetic field of the sun. We're seeing it in these solar storms. It's launching it at us. And the Earth will be the same way. I mean, it won't launch solar storms quite like this, but it when the dipole field component flips, other components take over. So I've talked about the quadrupole field. This is, a matter of fact, why we're seeing the poles, the South Atlantic anomaly beginning to pull into 2 different poles. It's because we're seeing the influence of these higher order components, okay? The quadrupole, the octopole, and then higher order. Quadrupole has 4 poles, right? The dipole has 2, quadrupole has 4, octopole has 8, right? And it goes on and on and on and on. And so we're beginning to see the influence of those, and so we're separating out. And when the dipole field completely flips, we will have a multipolar Earth, which means we'll likely have 3 or 4 poles, okay? And there'll be more at mid-latitudes, and we're kind of already seeing that. And I'm not so worried about geomagnetic storms. I'm not worried about the grid. I've talked about this many times. The magnetically induced currents are going to be weaker, which then actually relieves the grids. It makes it easier on them, by and large. You know, there'll be different parts of the grids that will need to be, you know, parts of the grid like down at lower latitudes that may not need to worry about geomagnetic storms right now, may have to start, but I don't think it's going to be anything, you know, outrageous. And really the big issue for me is more about aviation. Not only how are we going to deal with the fact that our compasses are going to be so radically different, but particle precipitation is going to be very different. And then also space out in actual near Earth space, what's going to happen to our radiation belts? Are they going to disappear entirely? Are they going to reform? If they reform and go somewhere else, well, now we might be in trouble because spacecraft that were designed for one kind of environment now have to live in a totally different environment. And what's that going to be? How quickly is this stuff going to happen? So those are the things that bother me. It's not so much geomagnetic storms at Earth and is it going to strip off our atmosphere. We've already shown, there's many papers out now that are showing that our upper atmosphere, our atmosphere is going to be completely protected in the quadrupole field. It's not a problem. So that in a nutshell is my opinion. And yes, I could go into more detail about it, but again, that could be a rat's nest that I'd stir up. So I don't know if I really want to do that. So that's why I haven't done one yet. Hopefully GPS could be bonkers. We'll see. Anyway, hopefully that answers that question. Okay. Yes, will migrations be affected? Absolutely. Everybody's going to be confused by it. But, you know, luckily it'll happen slowly. So hopefully the animals will, you know, be able to deal with it. And hopefully it'll happen slowly enough for us as well so that we have time to deal with the changes with different spacecraft builds, with different navigation systems and stuff like that. But it's something that is going to be, you know, eventually an eventuality, because eventually, even if it doesn't flip this time, it will eventually flip. But hopefully, you know, we'll be more technologically savvy, and space weather will be on everybody's minds at that point, so it won't be a surprise. Whereas right now, you know, we're still dealing with the infancy, and a lot of people don't even know how to spell space weather, let alone know what it can do. So that's you know, we're just at a vulnerable period right now. So, okay, guys, let's see. If SRUC satellites might suffer the same fate as those hit by the Starfish Prime. Well, no. Yeah, with a sudden radiation belt to contend with. From that perspective, yes, but totally different energy level. And I don't think of nearly as much mass, right? There won't be nearly as many particles. Starfish was very, you know, that was very, very different and very unique and very stupid, but whatever. When are humans intelligent? Right? We do a lot of stupid stuff. Oh, gosh. Okay. Let's see. I was recently reading a study that discussed sunspots with more unsigned magnetic flux are more likely to launch CMEs. Is unsigned magnetic flux distinguishable on a magnetogram? You know, that, Holly, that's an interesting question, and definitely not something I am set up to be able to explain right now. That might be something we'll just have to dive into in the future. Who was the study by? If you can put that up, I'd really appreciate it, because you know, there are so many opinions when it comes to predicting eruptions. Oh my gosh, I know so many different ways people look at twist underneath the emerging flux. I mean, there's just so many different things that people look for, and they try to look at it as a precursor for a solar flare or an eruption. And I've never seen more than about 50-50 on anyone's prediction. Basically, all we know is that when things become more complex, the probability rises. But can you actually predict when a flare is going to occur or when an eruption is going to occur? No, we still can't. There are lots of different ways of telling how, you know, what if a region is far more susceptible for, you know, to cause one, or the probability of a solar flare or a solar eruption is going to occur. But actually predicting when it's going to happen and predicting what's going to trigger it, big error bars. So that's you know. So anyway, I'd be interested to know what you've been you know, who you've been reading, so I'd have a better idea. But don't have anything on it tonight, and right now I'm going to probably wrap up, because I've got a couple moderators here who've been on with me for a long time, and they're East Coast, so I got to let them go. Okay, guys, thanks so much, and I will definitely read the rest of the comments, even if I didn't get to your question. If you're on Patreon and I didn't get to your question, please post it either in our community chat or on the comment section below the post with the live feed, okay? And enjoy and relax, and don't worry about the solar flares, but keep your eyes on region 3664, because I think that's the new big flare player. Okay, bye guys.